Welcome to Mathematics Lecture series. Our topic is domain, range, and codomain of functions. This is lecture number 3 in Applied Calculus series. Before the start the lecture, I request you kindly subscribe the channel. So here f of x is f of x to y. This set x and element of x is this set x is called domain. And this y set is called codomain, and the ranged element, image element f of x, this set is called range of the function. So range is always subset of the codomain, or those elements are imaged from the domain. So observe this example: x tends to 2x plus 1. Here A is set is domain, and the set B is codomain. The set A is the domain, the set B is the and the set of element that get pointed to in B. Those elements are imaged element, and the actual values produced by the function are the range, are also called the image. Domain: consider a real valued function y is equal to f of x from the set x to set y. The set x is called domain and the set y is called codomain of the function. The set of those elements of y which from the images of the elements of the set x is called the range of a function. We have studied in last lecture example number 2 in the last slides. You kindly, if you haven't watch, then you must watch the lecture number 2. We have the example x in which x is equal to 1 2 3 4 as domain, and y a b c d is a codomain of a function h and k. Range of the function h is the set act, and range function k is the set c. So another example, f of x 2x plus 1. It is function from real to real. Here x be any real number. Of course this x is any real number. When this number is used for x, there will be a corresponding real number f of x. We x replaced by any real number, then you will have corresponding value of f of x or y. The domain and range of this function f therefore includes all real number. Means we x, this x we can replace by any real number, so that the codomain is also all real number. Let's observe this example: y is equal to f of x x square. This is a function from real to real. Here x can be replaced by any real number, so domain is real number. But by replacing x, we have the y value or f of x value that must be a square, so it is must be a positive. So range is a positive real number. This function will be the set real number is always non-negative. Therefore, the range of this function will be the set of non-negative real number. But the codomain of this function is also a real number. So, in that example, the domain of the function is real number, range of the function is a positive real number, and codomain of the function is real numbers, all real numbers. Now consider a function f of x x 2x plus 3. Here x represents the length of one side of a rectangle, and 2x plus represents length of another side of the. Here x cannot be negative. So therefore the domain range of this function is the set of non-negative real numbers. Some observations. Remark: the domain and range of the function f are always denoted by t, f, or f respectively. In addition, observe Divided by another topic, divided by 0. Any value of x that creates division by 0 cannot be in the domain of function. Any value of x that creates division by that is not be in the domain. There would be no f of correspond to such in x. Square root of negative number. Any value of x creating the square root of a negative can't be in the domain of the function. Then there would be no real f of corresponding to such real number. X means x, if we divide x divides by 0, that is undetermined infinity, so it not belongs to real number. So because we here in calculus consider the function from real to real, and negative square root of negative number is a complex number, so it does not belongs to real number, so it is must be not in the domain. Find the domain of each of the following function. 1 over x minus 4. Here for x, if we put x is equal to 4, the denominator becomes 0. 1 over 4 minus 4, 1 over 0. Since the division by 0 is not defined, no f value is produced if 4 is used for x. Thus 4 is not in the domain of. This means that domain of f is the set of all real number except 4. Thus we can write df r minus except, because this 4 we apply and that 1 we have the 1 over 0 and it is not defined, so domain of r minus 0. Now observe this example, f of x square plus x. So we find the domain of this function. Here the domain of f is the set of all real number except 0 and minus 1. If you put 0, then you will have 0 upon 0. If you apply the minus 1, so here minus 1 and plus 1 minus 1 over 0. So those two number we subtract from the real number, and that is called domain of f. F of x square root x minus 1. If x minus 1 is negative, the result is the square root of a negative number. Since the square root of a negative number is not a real number, no f value will be present in such case. This means that the domain is all x values for which x minus 1. So x minus 1 here is a must be positive. If it is negative, we will have the negative. We will have the complex number. So x minus 1 greater than 0 means positive. So from here we x greater than equal to 1. That's the domain of the function from start. This start from 1 to infinity. So this is a domain. This interval is a domain of the function. Now similarly, it must be 3 minus 5x must be greater than equal to 0. That means positive 3 greater 5x or 3 we have from this 3 both side divided by 3 or 5 greater than equal to x, or we can say x is less than equal to 3 or 2. So though this under df infinity 3 over 5 is the domain of the function. Another two example, 3 plus x, 7 minus x, and bf of x minus 4 and x plus 1. So I suggest you kindly solve and observe these examples. Zeros of a function. As zero of a function, f is any real number x for which f of x is equal to 0. What is zeros of function? F of x is equal. Geometrically, it is a point where the function crosses or touches the x-axis. This is shown in the figure below. It may be noted that function may have more than one zeros, or function may have no zeros, as shown in figure 2. Observe that graph that touches one time at the x-axis, so it has 1 0. Here this function have 3 0 because it touches the axis 3 times, and that function has 1 0, and that function has no 0. It doesn't touch x-axis. So how can we find the zeros of the function f of 5x minus 20? Just we have to write f of x is equal to 0, 5x minus 20 is equal to 0, from which we have by from which we have x is equal to 4. So at the point 4, thus the only 0 of this function is 4. F of x square 5x, so how can we f of x is equal to 0? Put it this is equal to 0. After solution we have 2 points, x is equal to minus 7 and 2. So we have 2 0 of that function. If we write the graph of that, touches at these 2 points minus 7 and 2. So last, observe this mod function f of x mod x absolute function. If we here observe this function goes cover whole x-axis, and domain of this x-axis minus infinity to infinity, because domain of x-axis minus infinity. If we observe the y-axis, so it could not be it could not cover negative y-axis, so range is from this point, this whole y-axis from the 0, so 0 to infinity is the range. And what is codomain? This is of course in calculus, this y-axis, so codomain also from minus infinity to infinity. So we covered in this lecture domain, codomain and range. So I request you kindly subscribe the channel, like the video and share with friends as you find more videos on the mathematics topics. Thank you.